Next question. Let's look at another question on growth and decay problems, which is an application of first order ordinary differential equations. The question here says it is known that a certain radioactive element is decaying. What comes to mind there? Negative. Is decaying at the rate proportional to what there? The amount present. So let's just write that one very quick. No, let me read first. To the amount present, full stop. It was observed that the original material lost what there? 30% of its original mass after how long? 4 hours. Where its original mass was initially 50 milligram. Full stop. I obtain an equation for determining the amount of material present at any time t. Number 2, what is the mass after 5 hours? Number 3, what is the half-life of the radioactive element? Let's get this done. First things first, look up please. They said it is decaying at a rate proportional to the amount present. Now, that is simply this. So A part, let's start with A part. It is decaying at a rate, so the t is equal to minus kt, or let's start with this minus what? X, decaying, negative. So we have that dx dt, we have that dx dt is equal to negative kt, yeah. T comes down here, the t, no, minus kx. Is minus kx, please. All right, x comes down here, the t goes here. I'm having dx over x is equal to minus k dt. This gives you what there? Integrate this, integrate this. If I integrate this, I'll have what there? Ln x is equal to what do I have here? Minus kt plus c. We'll have this, right? This gives you what there? X is equal to what there? Exponential minus kt plus c, right? Take exponential of this. So x is equal to exponential minus kt times exponential c, right? When they multiply, you see plus of this. We've done this already in our previous class. So please check our previous class for the full step-by-step guide to this. This is just a revision of this. From here, we said a should be equal to exponential c. So we'll have that x is equal to, this is a, so it becomes a exponential, what I have here, minus kt. So we have this one initially. So I said we've solved this in a step-by-step class. So please check our previous class for the step-by-step guide on how this is done. For this one here, I'm just revising this. All right. Let's take in conditions here. They said, what was the initial value, please? What's the initial value? Check your question there. What's the initial value? Or initial size? What's the value? They said when it was what there? Initially what there? 50 milligram. That means at t equal to 0, x is what there? 50 milligram. Right? That's it. So impute it here. What do you have there? 50 x is equal to a exponential minus k times t. What's t there? 0. This is equal to a into this one here, a minus k times 0 is what there? 0. Exponential 0 gives you what there? 1. 1 times a is what there? A. In essence, a is equal to what there? 50. You've gotten a. That's the first thing there. If I put the value of a into this equation, I'll have that x is equal to, they said a is 50, so it becomes 50 exponential minus kt. I have this. Okay? What's next in there? Please check. They said it was observed that the material lost what? 30% of what there is original mass after what there 4 hours. So at t equal to 4. Again, we're working with hours now. So it's 4. At t equal to 4, what's the value of x? What's the value of x? Huh? At t equal to 4, what's the value of x? How do you solve it? What do you get? They didn't give us an actual value, right? This is what happened there. It lost what there? 30% of the original. So how do you get the value? It's just simply the original. It lost 30%. 30%, that's 30 over 100 times the initial. This is how you do that. That's simple. It lost 30% or 0.3 of the original. From here, x is equal to, please give me the value here. This gives you, this cancels this cancels this is 15. So it becomes 50 minus 15, what do you have there? 35. So please, the value is not 15. The value is what there? 35 milligram. It lost 30%. What's the value of 30%? 15. It lost that amount. So it becomes the initial amount minus that's the one it lost. That's 50 minus 15. This is 15. And that's 35. Please get your word problem mindset set. Right? Okay, putting these conditions into your equation, I have that 35, this one here, 35 is equal to 50 exponential minus k into t. What's t there? 4. After 4 hours. Right? It lost this thing after 4 hours. So help me out here. First things first, divide here by 50. Divide here by 50. This cancels this. Give me this value, please. 0.7 on the dot is equal to exponential minus 4k. Right? Minus k times 4 is 4k. All right. What do we have here? Taking on both sides. Ln of 0.7 is equal to ln of exponential minus 4k. From here I have ln of 0.7. It's equal to, for a case like this, ln will cancel exponential. I'm left with minus 4k. To get the value of k, divide here by minus 4, divide here by minus 4. This cancels this. This will give you a negative. So that means k will be equal to, give me a final answer, it should be positive. Because this will give you negative over negative. Just punch this. What's your final answer? 0.0892. Well approximated. Alright. So you have this. That means that x is equal to 50 exponential k minus k 0.0892t. This becomes the expression that is required. So when they say obtain an expression, obtain an equation for determining the amount of materials present at the time t, this becomes the required equation, please. Let's do B part. B part says, what is the mass after 5 hours? So T is equal to 5. Now the mass is what represented as what there? K. The mass is K. That's a K is in milligram. That's the mass. So at T equal to 5, you have that X is equal to, the equation there is 50 exponential minus 0.0892 times T. What's T there? 5. So please give me final answer, please. 32 on the dot. 009 00. Okay, just take it 2. It's 2. The mass, put the unit there, milligram. So you can see it is reducing. That's why it says decay. So at t equal to 4 hours, if you want to, 4 hours, it's what there? 35. So as the time is increasing, what happened to the mass there? It is reducing. So when t increased from 4 to 5, what happened to it there? It reduced from what there? 35 to what there? 32. When time is increasing, the mass is what there? Reducing. That's why it's called a decay problem. Boss, what's the problem? And boss, what's the problem? See, what is the half-life? Right, half-life of the radioactive element. What's the half-life? What's the half-life? Physics, what's half-life? Physics, what's half-life? Physics, what is, how do you define half-life? Physics. Decay. So if it's time taken, that means 5 is a half-life, 4 is a half-life. Half-life is simply, it's the half of the life. The time it takes a material to lose half of its initial size. That's half-life, the time. So half-life is a constant of what there? Time. How long will it take the radioactive element to do what there? Lose half of its initial what there? Value. In essence, half-life, we're looking for T. What's the half-life? The time, we don't know. But here's the condition. For half-life, X will be equal to what there? 50% of the initial value. That's why it's a half-life. That's it. So in essence, X is 50% is what there? 0.5 times, the initial value was what there? 50, right? 50 times 50 milligram. That's what there? 25 milligram. So at half-life, the size should be what there? Half. 25. So it means find T at X equal to what there? 25. How do you solve that? Simple. X is now 25. So it becomes X 25. It's equal to 50 exponential minus 0.0892 times T. What's the time there? See, we don't know. To solve this, my first task, divide here by 50. Divide here by 50. $25 by 50, what up there? 0.5. 0.5. It's equal to, this cancels this. I have exponential minus 0.0892 t. I have this. Obviously, my next task, take ln of both sides. Ln 0.5, it's equal to ln exponential minus 0.0892 t. All right, ln 0.5, it's equal to, ln cancels exponential, I have minus 0.0892 t. To get the value of t, I'll divide here by minus 0.0892. Divide here by minus 0.0892. This cancels this. So I'll have that t is equal to, what do you have here, please? 7.77 what? So don't worry. That's seven. Time was in hours, in years, or what? In hours. Right. So this talk about 7.77 hours, which is approximately what there? 8 hours. So basically, this is how we solve this question. If you check your text, some authors will say for half-life, this will not be equal to what there? T over 2 is equal to 7.77. I do not see the head in that thing. Some authors will tell you that half-life T is actually T over 2. Why is T over 2? Like if go to, this is where the half-life concept affects it. So if you check that your text, he said T over 2. It's not T over 2. It's T over 2. But then still do your research anyways. But basically, this is how we solve this question. Any questions, please? All right.
Get more by joining our Differential Equations channel membership or visit www.johnnymanual.com/courses and get the Differential Equations Made Easy course. Both links in video description. Get more by joining our Differential Equations channel membership or visit www.johnnymanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.